students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting and a very relatable topic, that is understanding shapes. Now in this chapter we will learn about the introduction, parallel and transversal lines, what are the pair of angles and angle formed when a transversal cut two parallel lines. Let's start with the introduction. We have studied about angle in class 6. An angle has a vertex, two arms. An angle AOC is written where two arms are AO and OC and is at vertex O. So these are our what? They are also called rays. Now let's look at the pair of angles. A combination of two angles is what? They are called the pair of angles. There are 5 pair of angles: adjacent, complementary, vertically opposite, linear pair and supplementary angles. Now let us study them one by one. Adjacent angle, let us draw an angle AOC, and here is our what? Ray OB. In between the two angles are formed with a common arm and common vertex. So the two angles, angle AOB and angle BOC, are formed having common arm OB and vertex O. So these angle forms are what? Adjacent angles. So two angles are said to be adjacent if they have a common vertex, common arm between the two arms. Now how we can check pair of angles are adjacent or not? Here are the working rules. Step 1 says that firstly we will observe whether the two given angles have a common vertex. Then we will observe that the two angles have a common arm. Then lastly we will observe if the other arm are on the opposite side of the common arm or not. If all the above steps are satisfied, that means the angles are adjacent angles. For example, here we have to check whether the pair of angles are our adjacent or not. So in the first given figure, here angle AOB and angle BOC do not have a common arm, so they are not adjacent. In the second one, they have a common arm, they have two arms and they lie on the same vertex. So these two angles are what? They are our adjacent angles. Linear pair. A pair of adjacent angles is said to be form of linear pair if their non-common arm lie on one line. So to check whether the pair of lines angles are linear, here are the working rules. Step 1 says that firstly we observe the two angles have a common vertex. Then we will observe whether the common two angles have a common side. And then lastly we will observe whether the two arms lie on a straight line, that is one straight line that is of 180-degree angle. And if all the above 3 steps are satisfied, that means they are our linear angle. Now always remember, the sum of measures of a linear angle is always 180 degree. Linear pair angles are always adjacent and adjacent may or may not form a linear pair. Example number 2, here we have to check whether they form a linear pair or not. Now in the first one, they have a common arm, common vertex and the other two arms lie on straight line, so they are linear pair. In the second figure also they have a common vertex, they have a common arm, that is EG, and the two arms lie on the same straight line, that is on the DF. So yes, they also form a linear pair. Now next is our linear pair. What are the working rules of linear pair? Now firstly we have to check whether angle A and angle B form a linear pair or not, and if angle A and B form a linear pair, that means angle A plus B is what? 180 degree. Then we will solve the equation and find the measure of each angle. And example number 3, in the figure, here we have given at right, find the value of x. These are the two which form a linear pair, and if we add these two, that is 2x plus 3x, then x is equals to 36 degree. Next is our complementary angles. Now two angles are said to be complementary if sum of their degrees is what? 90 degree. Now look at the following figures. In the first figure, two angles are 30 and 60 and 45 and 45 are what? Complementary angles. It is important that complementary need not to be adjacent. It is only the sum of degrees measured that determine whether they are complementary or not. Now how we can find the complement of angles? Now if two angles are complementary, then sum of their degree is what? Degree measure is 90 degree. Now when the measure of one angle is given and the another you have to find out, what you will do? Then you will find the complement angle is equals to 90 minus given angle. For example, here the complement of 10 is 90 minus 10, that is 80. So each angle is complement of the other. Next is our supplementary angles. Now two angles are supplementary if their sum of degree measure is what? Is 180 degree. Now how we can find the supplement of the angles? We know that two angles are supplementary if sum of their degree measure is 180 degree. When the measure of one angle is given, measure of another angle is what? It will become the supplement angle is 180 minus given angle is becomes the supplement of other. For example, here we have to find a supplement of 90, 180 minus 90, that is 90 is a supplement. Here we have to find a supplement of 0 degree, that is 180 degree. So solution number C, that is 180 degrees, is our correct answer. Now let's start with the vertically opposite angles. Now the angles opposite to the common vertex by the intersection of two lines having no common arm are called vertically opposite angles. Now let us prove vertically opposite angles. Like firstly, we have given two lines AB and CD meet at point O. Here is a point O, and forming the angles that are vertically opposite, that is angle AOC and angle BOD and angle BOC and angle AOD. So we have to prove these two angles are equal. Firstly, what we'll do? Firstly, we know that AOD and BOD, they are on the same pair, so they form a what? A linear pair. So they both equals to 180 degrees. Similarly, AOD and AOC, they also form a what? On the linear pair, so they also 180 degree. Now we know that they both form a linear pair, so they both equals to what? 180 degree. So we can put both of them equal. After equating these two, we get that one of the pair are equal. That means similarly we can prove that the another pair is also equal. We will draw an intersecting line, say L and M. Here we are making the angles A, B, C and D. Now using the protractor, we measure these angles and repeat the process. In case 1, first is 30, then 150, then 30 and then 150. In case 2, we have taken angle 60, 120, then again 60 and 120. So we prove that the property vertically opposite angles are equal is verified here very clearly. Now example number 7, in the given figure angle 1 is 40 degree, we have to find the measure of other angles. So we know that they form a linear pair, so that means AOD is what? 140 degree, and we know that AB and CD are what? Are the angles opposite to common vertex O, so that means they are vertically opposite. So angle BOD is equals to 40 degree, and by the linear pair BOC is 140 degree. Angle 1 is equals to angle 3 and angle 2 is equals to angle number 4, that is equals to 140 degree. Now here you have to check your progress, that which of the following statements are true or false. The sum of two angles which form a linear pair is always equals to 180 degree. Yes, it's a true statement. That's how you can solve the remaining ones. Let's start with exercise 7.1. In the first one, in the given figure given at the right, we have to find the value of x. So here the value of x is 3x plus 15 plus 2x minus 10, that is equals to what? 180 degree, and x is 5, x is equals to what? 175. So x is equals to 175 by 5, that is 35 degrees, our correct answer. That's how we can solve the remaining ones. Next is our parallel lines and a transversal. Now parallel lines, two lines in a place are called parallel if they do not meet when produced indefinitely on either side. For example, railway lines, opposite edges of a scale, a blackboard, floor of a classroom, these all are our examples of parallel lines. Now two or more straight lines are said to be parallel to each other if they lie on the same plane and do not meet if produced on either of the sides. Now in figure L, L is what? L is parallel to M, so we can write it as L parallel to M. Now the distance between parallel lines is same everywhere. Next is our transversal lines. A line that intersects two or more lines at a distinct point is called transversal. So here figure A shows non-parallel L and M cut by a transversal T. Figure B shows a pair of parallel lines which are cut by a transversal T, and figure C shows three parallel lines which cut by a transversal T. So in these figures the line T is what? This is not a transversal. It does not intersect L and M at different points. Now next is angle made by a transversal. When a transversal cut two or more straight lines and the angle formed are identified by different names by the virtue of their position. In figure transversal L, straight line M and N at P and Q respectively, and the 8 angles are marked 1 to 8 have their special names. So these are the special names. Interior angles are 3, 4, 5, 6 are interior angles. Exterior angles, that means those who are outside. Outside angles are 1, 2, 7 and 8. Pair of corresponding angles, that is 1, 5, 2, 6, 3, 7, 4, 8. Pair of alternate interior angles, that means that forms a Z inside. So that is 3, 5 and 4 and 6. Pair of alternate exterior angles, that means that form a Z outside. So that is 1 and 7 and 2 and 8. Now pair of interior angles on the same side of transversal, that is 3 and 6. and 4 and 5. Now next is our angle formed when a transversal cuts two parallel lines. Now in this figure, P parallel to Q, therefore transversal L cuts P and Q forming angles as shown. Then the angle of each pair of corresponding angles are equal. That means angle 1, angle 5, angle 2, angle 6, angle 3, 7 and 4 and 8 are equal. If the pair of alternate interior angles are equal, then angle 3 equal to 5 and angle 4 equals to 6. If the sum of each pair of interior angle on the same side is 180, then angle 3 plus 6 180 and angle 4 plus 5 is also 180 degree. Now from the above result, we can summarize that if two parallel lines are intersected by a transversal, then pair of corresponding angles are equal, pair of alternate interior angles are equal, sum of each pair of interior angle on the same side of transversal is 180 degree. Conversely, now if two lines are intersected by a transversal such that the angle of any pair of corresponding lines are equal, angle of any pair of alternate interior angles are equal, and the sum of interior angles on the same side of transversal is 180 degree, then the lines are also parallel. Here you can check your progress. Here you have to fill in the blanks. If two parallel lines are cut by transversal, then each pair of corresponding angles is equal. That's how you can solve the remaining ones. Next is our example number 8. Here in this figure, A parallel B, T is transversal. Angle 1 is given. We have to find all the angles, other measures. Now we know that angle 1 and 2 forms a linear pair. So angle 2 is 130 degree and angle 3 equal to angle 1. That means vertically opposite. So angle 3 is 50 degree. And we know that angle 4 is equals to what? Angle 2. Why? Because of vertically opposite angles. So angle 4 is also 150 degree. And we know that angle 5 is equals to angle 1. Why? Because corresponding angles. So this is also 50. And we know that angle 6 is equals to angle 2, corresponding pairs. So this is also 130 degree. And angle 7 50 and angle 8 is 130 degree. Now let's look at example number 9. Here in this figure we are told that AB is parallel to CD. Angle APQ and PRDs are given. We have to find X and Y. So here angle X is what? Alternate interior angle. That is equals to 60 degree. And in the next one here we know that they are forming a what? They are forming a linear pair, that is 60 plus Y. That whole is equals to our what? Alternate angles, that is equals to Y is equals to 65 degree and X is equals to 60 degree. Now in example number 10, here in this figure AB is parallel to CD, we have to find the value of X, Y and Z. So here BAD is equals to what? Angle A, D and C. So X is 30 degree and ABC is equals to DCB. So Z is our what? 80 degree. Now in triangle AOB, this is our triangle AOB. Here X plus Y plus Z is 180 degree. After substituting the value of Y, X is 30, Y is 70 and Z is what? Our 80 degree. Here in example number 11, we have to prove that two lines which are parallel to the same given line are parallel to each other. So let the two parallel lines are L, M parallel to the same given line, that is L parallel to N and M parallel to N. Now here we draw a transversal, that is T, respectively at A, B and C. Now since we know that L parallel to N and cuts transversal, so angle 1 is equals to what? Angle 3, corresponding angles. And we know that M parallel to N, so angle 2 is also equals to angle 3. And here from first and second equation we know that angle 1 is equals to what? Angle 2. And angle 1 and 2 are what? Corresponding angles which are formed by cutting a transversal T at A and M at B. So L parallel to M, and always note that the above property can be extended to more than two lines also. Now next is our example number 12. Here in this figure we have to find the value of X. Now through O, here we have to draw OP which is parallel to AB and CD which is parallel to OP. Now lines which are parallel to the same lines are also parallel to each other. So here angle POC and angle TCO, they are what? They are co-interior angles, and angle POC is equals to what? It is equals to 68 degree. Now we know that it is formed by two lines, that is angle BAO and angle POA. After adding these two, angle POA is equals to what? It is equals to 72 degree. And we know that X is equals to what? POC and angle POA. So x is equals to 68 plus 72, that is equals to 140 degree. Now let's check your progress. Here in these given figures you have to find the value of x. So here you can draw a parallel line, and here it is 55, again it is 38, and 55 plus 38 is our what? Is the value of x. That's how you can solve the remaining ones. Exercise 7.2, in the first one, here we have to state the property used in each of the following to make the statement true. If it is given that L is parallel to M and angle 3 is equals to angle 7, then it is our what? It is our a pair of corresponding angles are equal. That's how you can solve the remaining ones. Next is chapter and exercise. Here we have to take the correct option. Two adjacent angles have common arms, a common vertex, and a common arm for angle bisector. Or all of these. Yes, it's true. That's how you can solve the remaining ones. Mental maths in the following figure. Here we have given angle 3 is 61 degree and angle 7 is 118 degree. When you add both of these, that is 61, 9, 179. So no, they are not parallel lines. That's how you can solve the remaining ones. Next is our notes. Here we have said that Reena has drawn a figure and Sunita has drawn figure 2. Both of these are marked line L as a transversal. Which of who is wrong and why? So second is our wrong one, because it is between the parallel lines, not the intersecting lines. That's how you can solve the remaining ones. Here's the assertion and reasoning that you have to solve it by yourself, students. Now I hope you have understood the chapter pretty well. You just have to practice the exercise questions and don't forget to revise this topic again.